Okay guys, we're ready for section 6.5 now, sum and difference formulas. I've gone ahead and written those in for you on your notes, so if you want to pause the video and go ahead and write those in, feel free to do that at this time. And these are going to be identities that I'm not going to really necessarily make you memorize. They're not real difficult to memorize, but these are going to be given to you on quizzes and on tests. So just as a heads up, you don't necessarily need to memorize them, but through working problems, you probably will end up memorizing them at some point. The other thing is that you're also going to want to have this handy for this lesson. And so these are our exact values of sine, cosine, and tangent in quadrant 1. These are things that you should already have memorized. And so these are going to play an important role in what we want to do today. So there's not really room for that on the notes, but if you want to have that just next to you, that way you'll be able to know these exact values a little bit as we work some problems. Okay, so we're ready to kind of get going now. We're going to start in example 1. We're going to be finding the exact value of each expression without a calculator. So without a calculator, cosine of 165 is where we're going to begin. So I'm going to kind of zoom in here and we'll focus in on cosine of 165. Now, 165 is an angle in quadrant 2. And what my goal is to get that angle to be an angle in quadrant 1 using reference angles and using my, my sign chart, my all students trust castle. Okay, and so here's what I know. I know that in quadrant 2, right here, cosine is negative. So I'm going to have a negative here and then put cosine of the reference angle for 165 degrees. So if I were to think about this and just draw a little picture, if this right here is 165 and this right here is 180, then that's a difference of 15 degrees. And so that's going to be the same thing. Cosine 165 will be the same thing as negative cosine of 15 degrees. And now what I need to be able to do is I need to be able to figure out how am I going to get 15 degrees from the 3 angles that I know. That would be 30, 45, and 60. And so there's actually 2 options here. You can either do 60 subtract 45, or you could actually do 45 subtract 30, and either way, you're going to end up at 15. And so that call is kind of yours. You can do whatever it is that you want for this. And so what we're going to do here is we're going to rewrite this as negative cosine of, I'll just do 45 minus 30. And so now we're ready to go using our cosine of a difference formula, which is back up here. It's this one right here that we're going to use. Cosine of A minus B is the one that we're going to use for this particular problem. Okay, so here we go. That starts off with cosine of the first angle, 45, multiplied by cosine of the second angle, 30. And since we have a minus sign, this is going to change to a plus. And then we're going to have sine of the first angle, 45, multiplied by sine of 30. Okay, so that is now a unit circle contest. So do we know these exact values? Cosine of 45 is the square root of 2 divided by 2. Cosine of 30 is the square root of 3 divided by 2. Sine of 45 is square root of 2 divided by 2, and sine of 30 is 1/2. And so now for the final answer, I'm going to do 2 things. I'm going to distribute this negative that's right here to both of these numbers here, and then I'm going to actually multiply those numbers together. So negative root 2 times root 3, since both of those numbers are underneath a radical, I can write it as root 6 divided by 2 times 2, which is 4. And then minus root 2 times 1 is root 2, divided by 2 times 2 is 4. And so there I have my final answer right there. Okay, whoops, sorry about that. On letter B, we have tangent of 15 degrees. And so what I recognize is immediately that is in quadrant 1. And so I don't need to think about the things I needed to think about on example A, because 15 is already in quadrant 1. And so I'm just ready to do this. 15, again, we just talked about right back here, that 15 is either 60 minus 45 or it's 45 minus 30. I used 45 minus 30 on the first problem. On this one, I'm just going to use 60 minus 45, and it wouldn't really matter. You would end up with the same answer no matter what you did. Okay, so we're using tangent of a difference. That is the formula that is right here, tangent of A subtract B. And so this is going to be tangent of the first angle, 60, minus tangent of the second angle, 45, divided by 1 plus the tangent of 60 multiplied by the tangent of 45. And once we can figure out what all those exact values are, we're done. And so tangent of 60 is the square root of 3, minus tangent of 45 is 1, divided by 1 plus square root of 3 times 1, which of course is just square root of 3. Okay, on letter C, I've got an angle that is in quadrant 2, and I know that in quadrant 2, sine is positive. So this is going to remain a positive when I move this over to quadrant 1. The reference angle for 105 would be 75 degrees, because again, I'm comparing to 180. And so now I need to figure out how to get to 75 degrees. And that seems pretty obvious that I'm going to do 30 plus 45. So this is going to be the same thing as sine of 30 plus 45. And so we're going to be using our sine of a sum formula, which is this very first one back up here, this one right here, sine of A plus B, is what we're going to use in order to do example C here. And so here's what we've got. Sine of 30 plus 45 is equal to sine of the first angle times cosine of the second angle plus the sine of the second angle, which is 45, times the cosine of the first angle, which is 30. Okay, so sine of 30, 1/2. Cosine of 45, square root of 2 over 2. Sine of 45 is also square root of 2 over 2, and cosine of 30 is square root of 3 over 2, and so this ends up as square root of 2 over 4 plus the square root of 6 over 4. All right, so that's it for degrees. Now I'm going to do a couple of radian problems. And so in letter D, I've got sine of 7 pi over 12. Now 7 over 12, that's in quadrant 2. And so I'm going to move this to be in quadrant 1 by thinking about what the sine, S-I-G-N, of that is going to be. And so because we're in quadrant 2 and because it's sine, it's going to remain positive. And then the reference angle is going to be compared to pi, which is 12 over 12. And so if this right here is 7 over 12, then I'm missing 5 over 12 in order to get to pi. So 5 pi over 12 is going to be the reference angle, and so now this becomes sine of 5 pi over 12. Now, for radians, it's going to be helpful to think about these radian angles in terms of twelfths. And so if you'll look at the 3 examples here, D, E, and F, you can see they're all in terms of twelfths. And so kind of the reason for that is because if you look at your 3 angles in quadrant 1, they have a common denominator of 12. And so if we think of these in terms of twelfths, pi over 6 is going to be 2 over 12. Pi over 4, if I multiply by 3, that's going to be 3 pi over 12. And pi over 3 is going to be 4 over 12. And so now I've got to figure out, okay, which combination of those is going to either add or subtract to 5 over 12. And so what you hopefully see here is that 2 and 3 is going to add to 5 over 12. So this is going to become sine of pi over 6 plus pi over 4. Okay, once again, I'm using this angle and this angle in order to get up to 7 pi, or to 5 pi over 12. Okay, so now sine of a sum is going to be sine of the first angle, pi over 6, times the cosine of the second, which is pi over 4, plus cosine of, okay, I'm doing this a little bit out of order. I think just to not confuse you, I'll go ahead and stick to what I normally do, which is sine of the second angle, pi over 4, times the cosine of the first angle, which is pi over 6. Sorry about that. And so now we're ready to go with the exact value. So sine of pi over 6 is 1/2. Cosine pi over 4 is square root of 2 over 2. Sine of pi over 4 is also square root of 2 over 2. And cosine of pi over 6 is square root of 3 over 2, which ends up being square root of 2 over 4 plus the square root of 6 over 4. All right, on letter E, we need to, again, figure out how we're going to get to 1 pi over 12. And so, again, it's going to be helpful to look back at this to try to figure out how to get to 1 over 12. And so, hopefully, you're seeing there's two possibilities to get there. You could either do 4 minus 3, or you could do 3 minus 2, and it wouldn't really matter which one you did. Okay, so I think I'm going to do 4 minus 3. Again, it wouldn't really matter which one you ended up doing, but I'm just going to do pi over 3 subtract pi over 4. So pi over 3 minus pi over 4. And my cosine of a difference formula says cosine of the first times cosine of the second plus, sorry, wrong one. We want to do sine. Sine of the first, pi over 3, times the sine of the second, which is pi over 4. Okay, and so this is going to end up being cosine pi over 3, which is a half, cosine pi over 4, which is square root of 2 over 2. Sine of pi over 3 is square root of 3 over 2, and sine of pi over 4 is square root of 2 over 2. And you can see that this is, again, our familiar answer, root 2 over 4 plus root 6 over 4. Okay, on letter F, we need to figure out how to get sine of 17 pi over 12 into quadrant 1, and 17 over 12 is right now in quadrant 3. And so if I think about this, in quadrant 3, sine is negative, and so I want to change this to become negative sine of the reference angle. And so again, the reference angle is going to be in relation to 12 over 12, and so that's going to give me a reference angle of 5 pi divided by 12. Okay, so now I'm going to have this negative in the front for the entirety of the problem. I'm going to distribute that at the end, just like I did on example A. And so I need to figure out how to get to 5 pi over 12, and we did that earlier when we added 2 and 3. And so that's going to be pi over 6 plus pi over 4. So sine of pi over 6 plus pi over 4. And so using our sine of a sum formula, this is going to be sine of the first, pi over 6, times the cosine of the second, pi over 4, plus sine of the second, pi over 4, times the cosine of the first, which is pi over 6. Okay, and then once we get our exact values, we're good to go. So sine pi over 6 is a half, times the square root of 2 over 2, plus the square root of 2 over 2 multiplied by cosine pi over 6, which is square root of 3 over 2. And I'm going to go ahead and distribute that negative and multiply the numbers together, which is going to give me negative root 2 over 4 minus root 6 over 4. Okay, so that'll do it for example 1. You guys let me know if you have any questions as we move over here onto the second page. The second page is actually going to be a little easier, I think. We'll see about that, but for the most part, this is going to be, I think, easier to maybe understand than example 1 was, as long as you can identify which formula it is, and then you know your exact values. Okay, so on letter A, we have a sine cosine plus a cosine sine, and since those sine formulas on the front are the ones that are split with sine and cosine in a single term, I know that this is a sine formula. And because this is a plus sign and the sign stays the same, I know that this is also going to be a plus. So this is going to be sine of 25 plus 35, which ends up being sine of 60, and sine of 60 is the square root of 3 divided by 2. Okay, so that's it. That's all you have to really do is recognize which formula and then know the exact value. Okay, so on letter B, we have cosine of 20, cosine of 10, minus sine of 20, sine of 10. And so now I see that the cosines are together, the sines are together. That leads me to believe that this is a cosine formula. And the cosine changes, so because that's a minus, this is going to be 20 plus 10, which is going to give me cosine of 30. And cosine of 30 is also the square root of 3 over 2. Okay, so pretty straightforward, at least on the first two, and honestly, they don't get much more difficult than that. So on letter C, very straightforward. We know clearly this is a tangent formula because it involves tangents, and it's the sine in the numerator that you're looking at to see which sign this is going to be. So because that's a plus up there in the top, this is going to be 10 plus 20, which is going to be tangent of 30, which is the square root of 3 over 3. Okay, on letter D, I've got sine pi over 4, cosine of 11 pi over 12, minus cosine sine. And so since that is a mixed expression, I know that this had to have been a sine formula. And it's going to be sine of a difference because this is a minus sign and the sign stays the same. So pi over 4 subtract 11 pi over 12. And that's going to end up becoming, if I think about this as being 3 over 12, which is the same thing as pi over 4, minus 11 over 12, that's going to give me sine of negative 8 pi over 12, or same thing, sine of negative 2 pi over 3. Now, at this point, I'm going to be a little clever, and I'm going to use the fact that sine is an odd function. Sine is an odd function, and so what that means is that if I have sine of a negative angle, I can write that as negative sine of the positive angle, 2 pi over 3. Okay, so sine of 2 pi over 3, 2 pi over 3 is in quadrant 2. Sine in that quadrant is positive, so that means that negative right there is going to hang around. And the reference angle would be pi over 3, and sine of pi over 3 is negative square root of 3 over 2. Okay, finally on letter E, we've got cosine pi over 12, cosine pi over 12, minus sine of pi over 12, sine of pi over 12. And so this is going to be a cosine formula because I see that those functions are together like that. And because this is a minus sign, I know that cosine changes to a plus. And so I'm going to have cosine of pi over 12 plus pi over 12, which is 2 pi over 12, or pi over 6. And cosine of pi over 6 is the square root of 3 over 2. And by the way, it was just kind of a coincidence that 4 of the answers were either positive or negative root 3 over 2. It doesn't mean it's going to always be like that. It just means that I didn't do a great job of choosing examples, to tell you the truth. Okay, last problem, we're going to prove an identity. So we've got sine of alpha plus beta plus sine of alpha minus beta, and we want to show that that equals to 2 sine alpha cosine beta. Okay, so starting with this term right here, we're going to use our sine of a sum formula, which says sine of the first times the cosine of the second plus sine of the second cosine of the first. And then for this term, we're going to drag that plus sign down there, and we're going to use our sine of a difference formula, which says sine of the first cosine of the second minus sine of the second cosine of the first. Okay, so now here's what I notice. If you look at this term here and this term here, you'll notice that they are going to cancel out. And if you'll look at this term and this term, you'll see that they're exactly the same. And so if I add them together, then I'm going to get 2 of them. And so that'll be 2 sine alpha times the cosine of beta. And that is exactly what I wanted to show that left-hand side was equal to. Okay, that's going to do it for section 6.5. If you guys have any questions, please feel free to let me know.